All right, welcome back to another lesson, another set of practice for solving rational equations. It's just 4 more problems for us to go through. Remember, we're going to follow those same steps that we've done for everything else in this entire unit. First things first, factor, always, always. And then we're going to take the step of setting those denominators equal to 0 so that we can determine the domain restrictions, those excluded values. We will then get a common denominator so that we can add and subtract any fractions or any rational expressions on each side of the equation. We'll solve and then check our answers with those excluded values to see if everything we have works or if we have to eliminate an answer or two. So first example, 3 over 2x minus 2x over x plus 1 equals negative 2. Good thing about this one, you don't have to factor anything. You can jump right to finding the excluded values. Set 2x equal to 0 and x plus 1 equal to 0. So the two exclusions from the domain are 0 and negative 1. Now I need both of those terms in the common denominator, technically along with a 1 that is underneath the negative 2. So like if you need to see that dude there, you can put it there, but 1 times everything just gives you what you started with. All right, now we're going to process through. So in this set of examples, I'm going to go through and multiply each expression, each part, by whatever it doesn't have to make the common denominator. So the 3 over 2x has to get multiplied by an x plus 1 in the numerator and denominator, so it has that least common denominator. The next term has the x plus 1, so I have to multiply by 2x in numerator and denominator to get the common denominator. And the last term has nothing, so we have to multiply by both the 2x and the x plus 1 in numerator and denominator. All right, now that we have the common denominator, we really don't need it anymore for solving. We just have to look at the numerators. So it's 3 multiplied by the quantity of x plus 1, and then minus 2x multiplied by 2x, and that equals negative 2 multiplied by 2x multiplied by x plus 1. So use your distributive property, combine all those terms, we'll get 3x plus 3 minus 4x squared. On the other side of the equation, we only have a negative 4x multiplied by the quantity. We're going to take it one more step. I think piece by piece on that one helps us get it correctly. So 3x plus 3 minus 4x squared equals a negative 4x squared plus 4x. Combine your like terms. When we add that 4x squared to both sides of the equation, those are going to be eliminated on both sides. Love it. So now I have 3x plus 3 equals 4x. Subtract 3x from each side and you just get x equal 3. Okay, is that one of our excluded values? Nope. So that's an answer and we're done. Yay us. All right, let's try another one. Number 2, 6 over x minus 9 over x minus 1 equals 1 over 4. Again, nothing to factor. So state those denominators, set them equal to 0 so you can get the restrictions, x equaling 0. X minus 1 gives us a restriction of positive 1, and the 4 doesn't have an x. I need all 3 terms of 4, an x, and an x minus 1 as a common denominator. Multiply each part of the equation through by the missing terms of the common denominator. First one gets multiplied by a 4 and an x minus 1. Second term gets multiplied by a 4 and an x. The last term gets multiplied by x and then x minus 1. Again, drop those denominators. They're all the same. So that means the numerators are equal. And simplify. That'll give us 24 multiplied by x minus 1 minus 36 times x equaling x multiplied by x minus 1. Okay. 24x minus 24 minus 36 equals an x squared minus x, and then we can combine 24x and a negative 36x to give us that negative 12x. Now we're going to, because I have a quadratic term, I'm going to set everything equal to 0. I love that noise, it's great. Excuse that. All right, so when we set this equal to 0, we're going to add a 12x and add 24 to both sides of the equation. And then we'll combine our like terms to get x squared plus 11x plus 24. Now we have to factor. So we didn't have to do it at the beginning, but now we have to factor this quadratic trinomial. So do that work off to the side, whatever multiplies to 24 and adds to 11. And then that'll get you your factors. I need a positive 8 and a positive 3. And there we go. X plus 8 and x plus 3 are the factors. When I set each of those individually equal to 0, I'll get x to equal negative 8 and x to equal negative 3. Okay, check again. Are either of those an excluded value? Our excluded values are 0 and 1, which means, yay, again, both of those answers work. I love both of those solutions. They're great. All right, we've got 2 more. Let's power through. Number 3, x, that's just x over 1. Put the little baby 1 there if you need to see it. Minus 2 over x minus 3 equals x minus 1 over 3 minus x. Okay, we're going to take a quick little side note. Remember the x minus 3 and the 3 minus x, they're not identical twins, but we actually can rewrite that 3 minus x as a negative x plus 3. And guys, that's almost what I need. If I factor out a negative 1, then I'll have an x minus 3. So it'll have that common factor. Okay. All right, let's do our excluded values. X minus 3 equal to 0, so I get 3. And 3 minus x equal to 0 still gives me 3. So I truly only have one excluded value. They're the same. All right, and again, common denominator, I need a negative 1 multiplied by the x minus 3. That comes from this back denominator. I already have an x minus 3 for the first one and for that middle term, and the first term it has a 1, so it's going to need everything. All right, multiply through by everything that you need for each term. The first term, x over 1, I got to multiply by everything for that guy. So it's x multiplied by a negative 1 multiplied by x minus 3. I needed everything. The second term only needed to have the signs changed, so multiply by a negative 1. And then our last term, that one was perfectly fine. Remember, 3 minus x is equivalent to negative 1 multiplied by x minus 3. So it's written differently, but it is the same denominator that the others have. Okay, drop those denominators, giving us x multiplied by negative 1, or negative x, and then multiplied by x minus 3, minus a 2 multiplied by negative 1, so minus a negative 2. And that numerator of the last term, what it equals, that just stays the same, x minus 1. All right, we're going to use our distributive property, negative x multiplied by x, negative x multiplied by 3. And then I'll do a minus a negative 2 to give me the positive, and then we'll continue on. So negative x squared plus 3x plus 2 equals x minus 1. All right, gang. We've got another quadratic expression. So I want to set it all equal to 0 by subtracting x and adding 1 to the other side of the equation. Okay. So that will give me a negative x squared plus 2x plus 3 equal to 0. All right, what do we got to do again? We have to factor. Now, I will tell you this. If you don't want that first term of the quadratic equation to be negative, you can divide everything through by negative 1. Changing it to be a positive x squared, a negative 2x, and a negative 3 equal to 0, which is what I show in the next step. That will make sure that I have the correct signs when I'm going through and factoring. So we're going to look to see what multiplies to negative 3 and adds to negative 2. The only things that multiply to 3 are 3 and 1. I need a negative 3 and a positive 1. So there are my x's on top. So the factors are x minus 3 and x plus 1. Set them equal to 0 and solve to get x equaling positive 3 and negative 1. Okay, now check. x equaling 3. This is a restricted value, so that solution does not work. The only one that does work is the x minus 1. So even though we got two solutions, one of them, the x minus 3, was a restriction, so we had to eliminate it as part of our solution set. All right, we've got one more example, and we're done with this. 2m over m minus 1 plus m minus 5 over m squared minus 1 all equals 1. And again, 1 is the same thing as 1 over 1. Now, we do have to factor that first, or for the first time, the second denominator, the m squared minus 1. All right, if we just go straight to the excluded values, we set m minus 1 equal to 0 and we get 1. And if we set m squared minus 1 equal to 0, it factors into m plus 1 multiplied by m minus 1. So there's the factored form of that denominator that we need to look at for a common denominator. So you can factor it and then get the excluded values to be positive and negative 1. Or if you had solved as it is, you would have added 1 to the other side of the equation, and when you take your square root, you'll get positive and negative 1. Okay, so whichever way works for you. All right, again, least common denominator. Because that middle term has an m squared minus 1 as the denominator, when I factor it, I get two factors. I need both of those factors in every single denominator for all the terms of this equation. Which means when I solve the first term, first expression, 2m over m minus 1 has to be multiplied by the m plus 1. The second term plus m minus 5 over m minus 1, m plus 1. That's got everything, it's good to go. And the last term has to get multiplied by everything. Okay, so let's process through. 2m multiplied by m plus 1 is going to give us a 2m squared plus 2m plus m minus 5. And then when we multiply this back stuff over here, 1 multiplied by m minus 1, m plus 1, guys, that is this denominator over here that we already had. It's m squared minus 1. We saved ourselves a bunch of work. So now we have 2m squared plus 2m plus m minus 5 equals m squared minus 1. Combine all your like terms. Do it as many steps as you need, like combine the 2m and the m first. Then subtract your m squared and add the 1 over. Okay, we can do that. To set it all equal to 0, what do you think that's going to mean? Yeah, we're probably going to have to factor again. Okay, all right, so keep combining like terms. We will get down to m squared plus 3m and then minus 4. 2m squared minus m squared is m squared. 3m is its own dude. Negative 5 and a positive 1 gives me the negative 4. All right, yes, we do have to factor because we have another quadratic trinomial. What multiplies to negative 4 and adds to positive 3? We've got 2 and 2 and 1 and 4. Let's use the 1 and 4. Negative 1 plus 4 is 3. Cool, negative 1 multiplied by 4 is negative 4. So there's our factors, m minus 1 and m plus 4, all equal 0. Set them individually equal to 0 and solve to give you m equaling negative 4 and m equaling positive. The m plus 4 equals 0, so m is negative 4, and m minus 1 equals 0, so m is 1, but that was a domain restriction, so we can only use m equaling negative 4 as our solution. Great job yet again, and we are done.